Okay, so today we're going to talk about functions. All right, we'll start with the definition. What is a function? Well, a function is going to call back to what we did last in the last lesson, which were relations. A function is a relation, but it's a special type of relation. It's a relation in which each input, has exactly one output. A function is a relation in which each input has exactly one output. Think back to the relations lessons. Remember that an input is also the x value, okay? And your output is the y value. So another way of saying that is that a function is a relation in which each x value has exactly one y value. Okay. And since we're going to be dealing with ordered pairs and tables and graphs more often, instead of input and output, always think x and y. Okay. One thing to note is that a function is a relation. We said that. All functions are relations. So every function is a relation. Okay. However, not all relations are functions. But not all relations are functions. So today's lesson is going to be how to determine a function given the four ways we represent relations. Okay. How do we determine what a function is before we even deal with what we do with functions? So today's all about how do we determine which of these relations are functions. Because remember, all functions are relations, but not all relations are functions. So we got to figure out how do we define which relation is a function and which one's not. Okay, so how to determine a function from the four representations of relations. Okay, remember the four. They were ordered pairs, tables, graphs, and mapping diagrams. First up, we'll do ordered pairs. I'll just number them. Remember, ordered pairs are x comma y. If you have a relation, you're just going to have a bunch of ordered pairs listed out. Okay. All right, so for a relation that's given to you in ordered pairs, for those ordered pairs to be a function, they cannot have any repeated x values. So you'd have to go through and read every ordered pair and see if any of the x values are repeated. If they had repeated x values, they would break the definition of a function, okay? Which is that each input, each x value only has one output. So if there are repeated x values with different outputs, it breaks the definition. So ordered pairs cannot have repeated x values. If they don't have repeated x values, then it is a function. If they do, then it's not. For example, let's write out a relation. Okay, remember, for ordered pairs, relations are written just as inside curly brackets and then all the ordered pairs listed. Say inside our curly brackets we have the ordered pair 1, 2. And then the ordered pair 3, 4. And then the ordered pair 1, 0. And then end your curly bracket. That is a relation. But is this relation a function? All you have to do is look at all the x values. Remember, x comma y, x is going to be listed first. So our first x value is 1. The second x value is 2. The third x value is 1. Okay. Since these two match, those are the same. There is a repeated x value, which means this is not a function. So this is a relation, but it's not a function. All right, next up was table. Remember, table is just a more organized kind of vertical or horizontal way of expressing ordered pairs. So tables have pretty much the same definition. In a table, you cannot have repeated x values in the X row or the X column, depending on if you have a horizontal or a vertical table. So again, it's pretty much the exact same thing as the ordered pair. All right, so let's see an example. I'll do a horizontal table of my X, of a Y, and the units, the entries to this table are going to be, let's see, the first one will have, see, in the X row we'll have just 1, 2, 3. And the Y column, or the Y row, will have 8, 7, 8. All right, so just go through your definition. For a table to be a function, it can't have repeats in the X row or the X column. Okay, so look at the X row. The values in the X row are 1, 2, 3. There's no repeats. Okay, which means this is a function. Now, a lot of kids point out that there's repeats in the Y column or the Y row. There's 2 8s here. Doesn't matter. You could have repeats in Y. You cannot have repeats in in X. You could have repeated Y's, but you can't have repeated X's. Okay, again, and it all just goes back to the definition. Each input, each X, only has one Y. Okay. They could all have the same Y as long as each X is unique. Next up is the graph. So the graph is where things differ, but again, it's all based around the same definition. So the graph has this test that we use. It's called the vertical line test. I usually abbreviate it as VLT. So the vertical line test states that to be a function, any vertical line that's drawn on the graph, so any vertical line that you can draw, can only pass through the graph one time. So to be a function, any vertical line can only cross the graph in one spot. The vertical line test. It's also called the pencil test sometimes, because what it means is anywhere you place your pencil on the graph, it can only cross the actual graph once. Okay. So let's look at 2 examples of graphs. So I'm going to draw 2 similar graphs. The first graph is going to look like an S. And the second graph is going to look like a kind of a rotated S, kind of more like a roller coaster. One of these is a function, one of them is not. Okay, so again, because it's a graph, that means one of them fails the vertical line test and one of them passes the vertical line test. So again, let's read the vertical line test again. Vertical line test states that to be a function, any vertical line can only cross the graph in one spot. So what that means is if you could draw a vertical line anywhere on the graph and it can only cross the graph once. So let's draw a vertical line on this first graph. Do it in red. Okay. How many times does that vertical line cross the graph? Well, it crosses it up here, it crosses it down here by the x-axis, and even crosses it a third time down there. So what that means is that fails the vertical line test, which means it's not a function. What about the second one? Okay, we'll draw a vertical line on this graph. Doesn't matter where you draw it. You even draw more than one. Doesn't matter where you draw these lines because they only cross the graph one time. Okay, it crosses here, crosses here, it crosses here, but it doesn't cross anywhere else. So this graph passes the vertical line test, VLT, and if it passes, that means it is a function. So again, all it takes is one spot where a vertical line might cross the graph more than once. So just one time it has to cross more than once, it automatically fails. And then to pass, it means you could draw a line anywhere, and it's only going to cross once. The last representation, if you remember, was the mapping diagram. In the mapping diagram, again, all of these are based out of the same definition, that each input can only have one output. Now, in a mapping diagram, remember, there were arrows pointing from the X circle to the Y circle, from the input circle to the output circle. Those arrows are important. For a mapping diagram to represent a function, only one arrow can come out of each X value. Only one arrow can come out of each X value. Or kind of the opposite of that is that you can't have more arrows. You can't have more arrows than numbers in the domain. Can't have more arrows than numbers in the domain. Okay. So if you have two numbers in your domain, but there's three arrows, remember the domain is the first circle. The X is the inputs, the domain, all the same. If you have two numbers in there, but there's four arrows, it's not going to be a function. So let's draw some mapping diagrams, and then we'll be done. Remember, so we've got two circles, two ovals. Okay, so I got my two mapping diagrams. Now I'm going to fill them in. One of them is going to be a function, one of them is not going to be a function. All right, so we got, remember, you have your X circle is first, and then your Y circle, or sometimes your input and your output, your domain and your range, all the same. Okay. This first X circle, I'm going to put 1, 2, 3. Okay. And in the Y, I'm going to put 4. And now I'm going to draw my arrows. And they're all going to point towards 4. All right, the second setup, I'm going to put 1, 2 in the X, 3, 4 in the Y. And then I'm going to have an arrow pointing 1 to 3. I'm going to have an arrow pointing 2 to 4. And I'm going to have an arrow pointing 2 to 3. Okay. One of these is a function and one of them is not. Okay. Now go back to what our definition was here for a mapping diagram. Only one arrow can come out of each X value. Or your alternate, you can't have more arrows than numbers in the domain. And again, domain meaning the X. Okay. So it should be fairly obvious that this first one is a function. Each number in the X circle only has one arrow coming out of it. There's 3 numbers in the X circle, there's 3 arrows. So that is a function. Okay, which makes this one not a function. Why is it not a function? Well, there are 2 arrows coming out of the 2. You can't have that. Again, and then the alternate definition, there's 2 numbers in our domain. There's 2 numbers in the X circle, but there's 1, 2, 3 arrows. So this is not a function. And that is the definition of a function. I'm going to pull up some more problems here in a second, and we'll look at those examples too real quick. But before that, a quick recap. Mapping diagrams. 1 arrow coming out of each X value. Graphs. Has to pass the vertical line test, meaning any vertical line can only touch the graph in one place. And then tables and ordered pairs, you cannot have repeated x values. Okay? For those, and that's for those to be a function. And again, a function is a relation in which each x value has exactly one y value. Each input has exactly one output. Okay, so these are just 6 more examples. If you want to pause the video and try to determine which of these 6 are functions and which ones are not functions. Okay, so let's run through these real quick. Hopefully you paused it and just said if function or not a function. This first one, ordered pairs. So if it's ordered pairs, we're looking at only the x values. Okay. So I got a 3, I got a 1, I got a 2, I got a 3. Right away, 3 just repeated, so I know this is not a function. Okay, because you got the repeat 3s. Okay. So this is not a function. Just put no. What about the mapping diagram? Remember, for a mapping diagram, you're looking at, are there more than one arrow? Is there more than one arrow coming out of an x value? Okay, and this one's, mapping diagrams are pretty obvious. Right here, we got 2 arrows coming out of there. So this one is automatically not a function. The graphs. The graphs have to pass the vertical line test. So draw some vertical lines. Is there anywhere on this graph where I could draw a vertical line that's going to cross the graph in more than one spot? And the answer is no. All of these lines cross only once. Which means that, yes, this is a function. The second graph. So these graphs look very different. And I'll explain that in a second. The second graph is just dots. Okay. Well, it still needs to pass the vertical line test. So any vertical line, all that means is that anywhere on this graph, there's no dots that are kind of above and below each other. So any line you draw through these, any vertical line you draw through it, there's only one dot that it's going to cross. So this one's also a function. Now these graphs have names, and this is just extra content here. This one's called a continuous graph because you could trace the graph without picking up your pencil. Okay, so they're lines. This graph is called a discrete graph, meaning there's just individual points on it. But again, discrete and continuous graphs, for them to be functions, still have to pass the vertical line test. Okay. Back to ordered pairs down here. Look at your x values, -2, 3, and 4. Those are all different. This is a function. And then the table, only looking at the x column, don't care about the y column to determine whether it's a function or not. -2, 0, 1, 4, all different, no repeats. So yes, that is a function.